All right, your last section. 6.8 is dividing polynomials. I'm going to give you your first example and then we will talk through them. I want you to notice that I'm writing it really high up on the screen right here because I know that as I show you how to do this, I'm going to have to rewrite it. So, negative 9 z to the 7th plus 18 z to the 3rd divided by 9. There are two ways to solve dividing polynomial problems. Each problem will use one or the other, okay? The first way is what I'm about to show you. And the reason that we're going to use this method is because we look at the denominator, and the denominator is a single term, one term. That means that there are no add or subtract signs in the denominator. Because of that, I can rewrite these into two separate pieces for me to solve. So what I mean is in the numerator, here's my add sign. So this is one piece here, and this is the second piece. So the first piece I rewrite over the denominator. I bring down the plus sign, and I rewrite the second piece over the denominator. And I look at this as two separate pieces. You can think about it like this. This is a fraction, and both of those pieces on top, they don't match, so they can't be added together, but they both have a common denominator, and they're both over 9. So if I rewrote them as two separate pieces, their common denominator would still be 9, and that's what we did. So I look at these two separate pieces, and I'm going to start with the term on the left. So that's negative 9 z to the 7th divided by 9. I can simplify 9 and negative 9 by dividing by 9 on both of them. Okay? Z to the 7th, there's nothing in the denominator that can simplify with z to the 7th. You can't do anything in the diagonals because this is an addition problem, okay? So that doesn't happen. So what do I have to bring over? Right now I have negative 1 z to the 7th, okay? The denominator I have 1, so I don't know what I'm going to have in the end for both pieces, but we're going to mess with that in just a second. For this one, I'm going to divide by 9 and get 1, divide by 9 and get 2. There's nothing that z to the 3rd can simplify with, so I have plus 2z to the 3rd. They're both over 1. Anything with a denominator of 1 is just the numerator itself. It's a whole number. So negative 1 z to the 7th plus 2z to the 3rd is my final answer. Why am I not adding z to the 7th and z to the 3rd? Well, because they are not like terms. Okay, just like in the last sections we've talked about, we combine like terms. Remember, if I have 3x and negative 2x, these two can go together and bring x over for my answer because the labels matched. And these down here, I have z to the 7th and z to the 3rd. They do not match, so this is going to be my final answer. Let's try another one. Negative 12x to the 4th plus 8x to the 3rd minus 4x squared, all divided by 4x squared. All right, so can I use that same method that I used in the first problem in the second problem? Meaning, can I rewrite this as 3 separate pieces with 4x squared as the denominator of each one of them? Yes, I can. The reason I can is because that 4x squared in the denominator does not have any add or subtract signs in between it. Because it's one term, it's all together, no add and subtract signs, we can rewrite it like this. Okay? All right, we're going to look at each piece individually from left to right. So what can I divide by on the far left piece? Divide by 4 and I get 1. Divide by 4 and I get negative 3. All right, the rules for division, signs are different. The answer is always negative. 4 goes into 12 3 times, negative 3. The next piece I have is this guy. I have x to the 4th divided by x squared. The bases match, so I will subtract the exponents. 4 minus 2 is x squared. So this whole piece went away and all I have is x squared in my numerator. What did I finish out that whole section with? Negative 3x squared in the numerator over 1. Okay, move on to the second piece. I can divide the top and bottom both by 4 on both of these. Remember, to simplify, you have to divide both the top and bottom by the same number. I ended up with 2 on top and 1 on bottom. This piece right here, the bases match. It's a division problem, so I'm going to subtract the numerator minus the denominator exponents. 3 minus 2 gives me x to the first, which is just x, and this piece is gone. So I ended up with 2x over 1 for this piece. The last piece, I'm going to divide the top and bottom both by 4 and get 1 on both the top and bottom. And the bottom here, or the exponents here, I have bases match. I'm going to subtract the exponents, and I have x to the 0 power. Anything raised to the 0 power is 1. So what I have is 1 times 1, which is just 1. So what did I end up with completely here? I have negative 3x squared plus 2x minus 1. Where did I get the add and subtract from? Well, the negative is here, that add is here, and the subtract is here. I brought them with them. Remember, whatever's in front of it goes with it. That's still the case. And so this is my final answer. X squared, x, and a number. They're in descending order, so this is it. Okay, let's look at another one. Last one, example of these. Negative 5y to the 14th plus 10y to the 6th, all divided by 5y to the 5th. The denominator has no add and subtract signs, so I can rewrite it as separate pieces. Okay, I look at this far side over here and I divide the top and bottom both by 5. This has bases that match. I subtract, and I end up with y, I think it's not, yep, 9. Okay, so I have negative 1 y to the 9th. In this piece, I divide by 5 on the top and bottom, and I get 2 over 1. Here I take my bases, I subtract my numerator minus my denominator, and I find y to the first, which is just y. And so I end up with plus 2y. I have negative 1 y to the 9th plus 2y, final answer. Okay, the next part, I'm going to write a problem, and it is going to look different on purpose, okay? Sorry, that's x. Okay, this problem is different because my denominator now has a plus sign. It could be a subtract sign too, but it now has an add or subtract sign in the denominator, and it makes us solve this differently. We cannot rewrite this in individual fraction pieces and simplify like we've done in the first 3 examples. We have to do this in a different way. I want you to realize that whatever's on the top is the piece that you are going to divide into. Whatever's in the denominator goes on the outside. So what you're looking at is long division of polynomials, okay? I'm going to take this piece up here, and I'm actually going to kind of squish it because we don't need it really anymore. This is how we started, but this is the piece that we're dealing with now. Please notice that I'm trying to conserve as much space as I can because I know how long sometimes these can get. So here's what we're doing. The rules are really and truly to ignore everything else besides the outside far left piece and the inside far left piece. That's where we're starting. I ask myself, how did I make the outside piece become the inside piece? I multiplied it by what? Well, if I have x outside and I multiply it by x, I can get it to become x squared. So I need one more x. I want you to see that I have 2 terms outside, So I have 1, 2 terms here. This is where my first answer is going to go. And I'm going to put an X here. Okay, let me give you an example of what I'm doing. How do I get this to become this? Multiply it by 1. 1 times 3 is 3. When you subtract, you get 0. You bring your 6 down, and then we're going to move on to this other piece. What we're doing is we're going to do the same thing. We're going to multiply what we said at the top pieces times each piece over here. So x times 3 is 3x, and x times x is x squared. Okay. When I did this, I want you to see that 1 times 3 is actually just a whole number of 3. But what I did is I subtracted 3. And so remember that I can change the sign from subtract to an addition and then apply that negative to that number right there. So I actually changed all the numbers that followed, even though you don't see that you do that. That's the thinking. So I want you to see right here, this is going to be a subtract. Okay, I want to apply the subtract sign to everybody inside. Okay, so now the problem that I have is I want to combine or add 11x and negative 3x. When I combine them together, I end up with a positive 8x. How did I do that? I did 11 plus a negative 3. Signs are different. Subtract and take the sign of the bigger number, which was positive. Okay. All right, so the next piece I multiplied was x squared times, or x times x, which gave me x squared. I applied the negative to it, so now I have a negative x squared. When I combine these two right here, I get nothing. That is the goal. That's why I ask myself, what do I do to this guy to make it become that last piece in there, okay? All right, so I don't even have to put a 0. I just should always understand and know that that piece is going to cancel, okay? So now that I'm done there, I only have 1 piece here, and I have 2 on the outside, which means to continue on, I've got to bring down another piece, okay? Let me clean this up just a bit because that's a lot of mess everywhere, okay? Whoa, not that. Don't get that crazy, right? We're getting crazy. Okay, good enough. So we're at the same stage here. We brought down our 6, we brought down our 29 on the other side. All right, so we're looking back at the problem on the left. I have a new starting point, and the new starting point is here, right? It's a fresh new row, I'm starting over, and now I'm asking myself, how did I make my far outside piece become the far outside piece in the bottom row? So what did I do to x to make it become 8x? I multiplied it by a positive 8, right? Because 8 times x gives me 8x. 8 times 3 gives me what? 24. Okay. This is a subtraction problem. So I subtract. Remember that I'm going to change the sign and change the sign of each of the numbers inside. And so now what I have is these two cancel, right? $8, owe somebody $8, got $0. 29 and 24, their signs are different. Subtract and take the sign of the bigger number, and you end up with a positive 5. Since there is nothing else to come down, to bring down over here, I want you to see that what's on top is your answer, and what's on bottom is your remainder, okay? So in my open math, that's, sorry, I can't spell, Q-U-O-T-I-E-N-T is 8, x plus 8, and your remainder is 5. Quotient, answer on top, remainder is the remainder that you would have even from something that was left over. Okay, let's try another one. Okay. All right, this problem, a little bit longer. It's going to be x to the third minus 9x squared plus 98 all over x minus 5. Okay, I know I'm going to have to rewrite this to be x minus 5 on the outside, and then x to the third. I want you to see something here. I have x to the third, I have x squared, I have no x. And so in the problem, it's got to be a placeholder. Okay, let's look at the other problem. X squared, x to the first, a number. We weren't missing anything, but in this problem, there is no problem or piece or term that is an x. So I'm going to have to put something in as a placeholder for it for us to get the right answer. Okay, I want you to see that I put that in there. The 0x is the placeholder. Okay, here we go. How do I make my far outside piece become my far inside piece? I multiply by x squared. I need 3 of them. I have 1 here. I need 2 more for it to become x to the third. Remember, multiplication means bases match, add the exponents. And so I multiply x squared times negative 5 and get negative 5x squared. And x squared times x, and I get x to the third. Remember that this is a subtraction problem that I'm going to change to an addition problem, and I'm going to change the signs of the numbers inside. These two cancel. Signs are different. Subtract and take the sign of the bigger number and bring down my other piece. Okay, I'm starting over and I'm asking myself, how do I make my x on the far outside become the far inside piece? Multiply it by a negative 4 because, negative 4x because I need x squared. So x to the first times x to the first, I have 2 of them, that's x squared, and negative 4 times the understood 1 that's in front of here gives me my negative 4. So now I'm going to multiply negative 4x times both pieces. Well, negative 4 times negative 5 gives me a positive 20x. Negative 4 times x, negative 4x times x gives me negative 4x squared. I want you to know that this is a subtraction problem. I'm going to change the sign and change the sign of both numbers that follow. So this comes down to be negative 20x, and these two cancel. I'm going to bring down my plus 98. Again, I'm going to ask myself, how does my far outside piece become my far inside piece on the very bottom row? Well, I'm going to multiply by a negative 20. Now I'm at the point where I want to multiply the negative 20 times negative 5 and a negative 20 times x. Well, negative 20 times x is also negative 20x, and a negative is a positive. 20 times 5 is what? 100. I want you to know that this is a subtraction problem. I'm going to change it to addition and change the signs of both pieces inside. These two signs are different. Subtract and take the sign of the bigger number, and these two cancel. There is nothing else for me to bring down. So on top is my quotient. And my remainder is negative 2. The way that we write out our answers, the reason I'm showing you this box with the word quotient and remainder is because my Open Math will give you a box that says quotient, and then it'll have you put an answer in, remainder, and have you put an answer in. But the way that we really write it is what's on top, and the remainder minus, because it was a negative, 2 over whatever I divided by. It's a piece of the whole, right? So this is really how I would write my final answer. Okay, on your test, I think we tried to mimic what my Open Math did. So either way will be just fine.